Welcome back. So today we're going to be focusing on tangents and normals. So tangents and normals. So I think an appropriate question to start us off is, what is a tangent and what is a normal? So I'm going to draw a graph really quick over here. So ignore the shabby axes for now. So let's just say this x, this is y. Let's say y equals f of x. So this is a graph of y equals f of x. So let me get a different color. So the tangent is a line. So line, meaning it's linear, is a line that intersects with the graph y equals f of x at exactly one point. So in this case, let's say intersects at A, B. So a line that intersects f of x at A, B. So only once. So using this definition, we can also come up with definition of a normal. So a normal is perpendicular, so it forms a 90-degree angle, perpendicular 90 degrees with is perpendicular to a tangent, right? So visually, what that looks like is it's gonna be a straight line. It's not straight, but it's gonna be a straight line. Which forms a 90-degree angle with a tangent. So one can immediately notice that this has the same. This intersects the graph y equals f of x. The graph y equals f of x at the same point, a, b. So that's actually pretty useful, and we'll see why that is later. So right now, I think it's good if we move on to some practice problems. Yeah. So here we go. So let's start off with the equation y equals x power of 3 plus 2x squared plus 1. Let's say at x equals 0. So we want to figure out the tangent and the normal of this curve at x equals 0. So the tangent line and the normal line at x equals 0. So in order to figure this out, we first got to calculate the slope of the tangent, right? So how do we calculate slope? Well, we take the derivative of this. So we take a derivative of this. So, So in this case, I mean, dy dx equals to 3x squared plus 4x. So the 1 goes away because it is a constant, and when you take the derivative of a constant, that's 0. So now that we have the derivative, what we can do is we can find the gradient of the tangent line at x equals 0. So at our point x equals 0, and that is going to be equal to, just literally substitute 0 into this expression. So that's going to be 3 times 0 squared plus 4 times 0. And that is going to just be 0, right? So this, usually whenever the derivative is 0, let me just say dy dx equals 0. dy dx equals 0, then that point is considered as a stationary point. So stationary point quite literally just means, like visually, this is what it looks like. It's a horizontal line. So so if the derivative is 0, it's a stationary point. It means there's a horizontal line. That's a tangent line. But in this case, what we can do now is to find the tangent line. We can just say y equals to 0 plus 0x plus c. So this quadrature becomes y equals to c, right? So if we plug in this 0 up here into this, we know that at x equals 0, y equals 1. So c equals 1. So the tangent line is equal to 1. So the equation of tangent line is equal to 1. Equation of tangent. Okay. Now let's try to do an example where we can figure out the normal. So let's say y equals to 2x squared plus 7x. So the process is very similar. Let's assign a starting value. So let's say x equals to 2. So again, we take the derivative. That's just going to be equal to 4x plus 7. And we evaluate the derivative at the given point. So we at x equals 2. That's just going to give us 8/15, right? So one interesting property is that the negative reciprocals, so the negative reciprocal of the tangent is equal to the gradient of the normal. So what I mean by that is, let's say m is gradient of tangent line. That means negative 1 over m is gradient of the normal line. So in that case, we know that y equals to negative 1 over 15x plus c. So again, we just start plugging in values and see where we go. So before we do that, we have to plug in this. Let me change back. We have to plug in this 2. We have to plug in this 2 into y. So in this case, we're going to get y equals to 2 squared plus 7 times 2. And we know that y equals to, so this is going to be 4. 4 times 2, 8. 8 plus 14, that's going to be 22. Yep. So we know that let me change back. We know that 22. Ooh, I don't like this purple. Let me change to something slightly lighter. Yep. So we know that 22 equals to negative 1 over 15 times 2 plus c. So 22 equals to negative 2 over 15 plus c. So now we know that c equals to 22 plus 1 over 15. So the equation of the tangent line is equal to y equals to negative 1 over 15. We can just say negative x over 15. negative x over 15 plus 22 plus 1 over 15. Or we could simplify that to negative x plus 1 over 15 plus 22. And there you have it. That's how you figure out the tangent and the equation of the tangent line and equation of the normal line. If you have any questions, please leave them in the comments, and thanks for watching.